Hello, so this is going to be the second part of RP1 and we're going to look at the titration today. I've previously done a video on the first part, which is actually making the standard solution that we use in the titration, so check that out. I'll leave a link in the description and the link in the video. In this video we're going to look at the method, the results table, how we're going to ensure accuracy, and finally we'll do an exam question. I'm going to leave the timestamps again in the description and in the comments, so you can just skip to the bits you're interested in. Before we start, I'm not actually a chemistry teacher, just so you're aware. I'm a chemistry student. I got an A-star in chemistry and I've just finished my A-levels. I'm going on to do a chemistry degree this year, which is cool. So this advice is just aimed at AQA students. Again, not a chemistry teacher, this is just what helped me to do well. So I'm going to dive right in with the method. Like I said before, visit the AQA practical handbook, copy that whole long method into a Word document and cut out the unnecessary bits that aren't really crucial for you to remember for an exam. That way you can revise more effectively and then just have like the crucial steps. So what I've done here, this is an example. I'm going to run through this method quickly because there are some things I like to explain in more detail. And also the following slides will kind of look at why each step is important. So this is just a brief run through. So first we're going to rinse the burette with sodium hydrogen sulfate solution. This is actually the standard solution that you made in part A, and we need to rinse that burette with the solution rather than with distilled water. It's a common mistake people make. Then we're going to fill it, and to do this we're going to use a funnel because we don't want to spill it everywhere. Then using a rinse pipette, we're going to transfer 25 centimeters cubed of sodium hydroxide into the conical flask. This is actually a volumetric pipette, which is a bit different to the little pipettes that you use. And we're going to again rinse it with that sodium hydroxide because that's what's going to be going into it. I'll expand on this in the next few slides. Then we're going to add a few drops of our indicator, whatever indicator you're using. Keyword here is few, not too many, because that will have issues further down the line. So then we're going to record the initial volume of the burette. So we're going to look at the burette and I'm going to read off how much of the solution we've added essentially. And then I'm going to place a white tile under the conical flask. This seems a bit weird, but it's just so that you can clearly see the color change that's going to occur. And then for the color change to occur, we actually have to do the titration. So we're going to open that tab for our rough titration, which is just want to see whereabouts the color change will occur. And this color change is actually called the endpoint. So then we're going to repeat the titration, now having a kind of rough idea of where to kind of slow down a bit and add drop by drop until we obtain concordant results. These are results within 0.1 centimeter cubed of each other. And then using those results, the concordant ones, I'm going to calculate a mean volume of the solution that we added from the burette, or simply I'm going to calculate the mean titra. Like before, I actually recommend drawing this out. Like, it's quite fun to revise in this way, and it's just a good way of, like, in an exam you could do a little sketch, and for 6 markers they accept a labeled diagram, which saves a lot of time. So I'd recommend doing something like this. It might be fun. Cool. And now for the results table. So this is quite a simple one. We have on the left you see our rough titration column. So this is the one just to get a rough idea of where that endpoint's going to be. It doesn't really matter. And then we have 4 subsequent titrations. Here we're going to know where that endpoint is going to occur, and hence we're going to add dropwise from the burette. So you have to hold the little tap and like really look to see how much you're adding. That's quite difficult sometimes, but it helps to ensure accuracy. Then you can see that I have the initial reading, the final reading, and therefore the titra for my little rows. This basically prevents you from messing around for an hour trying to get the volume exactly on 0. If you record what it is initially and what it is at the end, you can work out the difference and hence work out how much you've added. Finally, the concordant row, that I'm just going to tick it if the results for that titration are concordant, and I'm going to use them to calculate the mean titra. And to do this, I'm going to sum all of the concordant values on the top, and I'm going to divide that by the number of concordant values I've actually obtained. Again, concordant means that they are within 0.10 centimeters cubed of each other. So, moving on to a quite important section of this video, we need to make sure that our practicals are accurate. This is basically all they ask in exam questions. they'll refer to a particle and say, why isn't this accurate? How can it be more accurate? So this is what I focus my revision on. First thing, like I said, we have to rinse that burette with our standard solution. In this case, sodium hydrogen sulfate. But whenever you're doing titration, you're going to rinse that burette with whatever you're going to put in it. This is basically done to maintain the same concentration of that solution and prevent dilution. Because imagine if you rinsed it with water. What effect would that have? The solution that you subsequently put in it would be more diluted, because that's where, like, the definition of dilution, right? Adding water to something. So more of the solution would be needed to react with whatever is in the conical flask. You basically have to add more because it would be less strong. Therefore, we must keep the concentration of the solution, the burette, the same to ensure accuracy. Next, still with the burette, when we're actually putting that standard solution in the burette, you're going to want to use a funnel. You could write about this in your risk assessment even if you have to do this, because if you didn't, it would spill everywhere and that would be a massive hazard. So it's absolutely fine to use the funnel. However, once you actually start the titration, you have to remove the funnel. Because imagine, even looking at this image, when you're pouring that solution into the funnel, there's going to be little tiny drops that are still in that funnel. And when you actually start your titration, these are going to drop down probably into your burette. And this will make it seem like the volume has suddenly gone up, which is definitely not accurate as to what is happening. So again, we have to remove that funnel to ensure accuracy. Still with the burette, if you used one of these before, you know that between kind of the bottom of the burette and the little tap that you open and close, you're looking at the jet space there. And sometimes we might have unwanted air bubbles in that jet space. So we need to get rid of these. And to do this, we have to gently tap on the burette until they disappear. The key word here is gently. You don't want to be breaking a burette. But why are these bubbles actually an issue? Well, when you open the tap, the volume of the burette will decrease, right? Because the solution in it is coming out into that conical flask. That seems plausible. So the burette thinks that the solution is being added to the conical flask. Again, that makes sense because the volume is decreasing, so that liquid has to be going somewhere. However, the burette can't take the air bubbles into account. It doesn't know that some of that volume isn't actually filled by the solution. It's actually just air. So, although the volume decreased on the burette, so some of that liquid left and went into the conical flask, some of the volume was actually air rather than the solution, right? So the titration volume will hence be greater than what it should be. So again, to prevent that, we need to tap on that burette, get rid of those air bubbles. Cool, so when you're doing your experiment, you really want to know how to use the burette. So again, this idea comes up in chemistry all the time, but we read volumes from the bottom of the meniscus, and you need to be at eye level. So here's a good example on that left-hand side. You can see that the person's at eye level, they're looking at the bottom of the meniscus, and they can see that it sits on top of that 32 centimeter cubed line. And now, moving on to my worst enemy, the volumetric pipette. These are so ridiculously hard to use, so I'd actually recommend watching a video of how to use them before you do this practical in your lesson. But basically, these are quite good because they allow us to measure out exactly 25 centimeters cubed of the solution. So this is the solution that goes into the conical flask, in our case, sodium hydroxide. And because these can only measure out 25 centimeters cubed, they significantly limit uncertainty and make this much more accurate. First, like I said, we need to rinse this pipette with the solution that we'll be measuring out, sodium hydroxide. So we're going to prevent any dilution or contamination if the pipette is not clean. As with the volumetric flask, the pipette has a sort of graduation mark you can see circled up there, and that is quite good because we want the meniscus to sit on that, and we know exactly when we'll have 25 centimeters cubed of the solution. And then moving on to the conical flask. So we're going to rinse the conical flask with water at the start and between titrations. Because you can imagine, as we do each titration, you will have some residue left over, even if you put it down the sink. And so some of that burette solution, the sodium hydrogen sulfate, might still be left in that conical flask. So the amount of the that solution that we need to react with the sodium hydroxide would actually be less than what it should be because some of it's already in that conical flask. So to make sure that doesn't happen, we're going to rinse it with water between each titration. Also, when we add the indicator to the conical flask, we're only going to add between 2 and 6 drops because adding too much will affect the endpoint reading. Like I said before, we're going to place that white tile under the conical flask because this will allow you to see a clear color change. Imagine if you're doing it on a desk that was slightly pink, that would be so confusing. So you want that white tile. And we're going to swirl the conical flask during titration, as this ensures that the solutions mix together and react. This is partly the reason why you use a conical flask, because it will be much harder to swirl it in a beaker, it would go everywhere. So we're going to use that conical flask, it'll be useful for us. Cool, and then also continuing on with the conical flask, we can also rinse the sides with distilled water to ensure that all of the solution in the flask reacts, because you can imagine sometimes some of the solution will kind of just stay on the sides and not react. So we want to prevent this. They always love to ask, why can't we do this though? And the answer is always the same, because the moles of the solution in the flask will always stay the same. And also in this image down the bottom, there's a little mistake. Can you spot it? Yep, it's the fact that there's no white tile underneath the flask. And that's basically it in terms of kind of ensuring accuracy. So now I'd like to do an exam question. This is quite difficult. I remember when I did this the first time, I only got like 4 out of 6. So it's a good one to look at. I'll leave it up here for you to read. It's actually from the AQA paper, paper 1, June 2022. It's just recently been released on the AQA website, so check that out if you want. So have a read of that. Cool. And I've also added a bit of a hint, because like I said, this is a tricky one. So if you want to see that, keep watching. If you don't, pause the video. This is my hint. So for each of the 3 steps, I've actually identified the mistake. I've highlighted that in yellow there. So have a quick look at that. Again, if you want to have a go at this point, do that, pause the video. If not, I'm going to go on to the mark scheme and basically explain what's happening here. So, the first problem that I highlighted was actually using a measuring cylinder. And like I said before, the volumetric flask, pipette, as annoying as it is to use, it's actually quite accurate because there's very limited uncertainty. Whereas with a measuring cylinder, there's large uncertainty, because it can measure out many different volumes, right? So we're actually going to need to use that volumetric pipette. Next, you can see they added 5 centimeters cubed of indicator. That's actually a lot if you think about it. It's way more than 2 to 6 drops. So this is going to affect the endpoint reading. We do not want that. So we're going to add 2 to 6 drops. And then this does give 4 problems. You only need 1. You only need 3, so one of them is just extra, but choose any. Again, the problem, stage 3, is rinsing the burette with distilled water. Why? Because this will dilute the solution that goes into that burette. So instead, we're going to rinse the burette with what we're going to put in it. If you're going to take away one thing from this video, is that rinse the burette with what's going to go in it. Then last problem, it says that we are going to add the solution until the indicator just changes color. Just isn't really enough. We want a permanent and definite color change. We don't want any kind of uncertainty like is it or isn't it. So we want it fully to change color. And that's basically it for that question. Again, cover at least 3 of the stages fully if you can to get 6 marks. But if you do most of it, I think that might be enough. But yeah, hope that helps. I think I'm going to go on to do every practical. So yep, watch out for those videos.